All right, let's dive into the absolute cryptographic heart of Bitcoin, the digital signature. It's the magic that actually secures every single transaction. And we're going to break down exactly how it all works.
So think about this for a second. This is the central puzzle that Bitcoin had to solve. How on earth can you prove you own your money and give permission to spend it without ever showing anyone the master key, your private key? I mean, it sounds kind of impossible, right? But this is precisely the problem that digital signatures were built to solve.
You know, you should think of a digital signature as way more than just a squiggle on a screen. It's more like a unique, totally unbreakable digital wax seal. It's a mathematical proof that gives undeniable evidence about a transaction. So let's take a look at what that proof really accomplishes.
At its core, a digital signature isn't just doing one job. It's a cryptographic proof that's actually doing three super important things all at once: authorization, non-repudiation, and integrity. It's not just about saying, yep, I approve this. It's a multi-layered guarantee.
Okay, so these three ideas, they work together like this amazing shield for your money. First, you've got authorization. That's simple. It proves you, and only you, had the key to the lock. Then there's non-repudiation. That means the proof is so strong, you can't ever go back and say, nope, that wasn't me. It's undeniable. And finally, integrity. This means once the transaction is signed, it's sealed. Nobody can go in and secretly change the details. It's a triple threat of security, all in one neat package.
So, how is this digital seal actually created and then checked by everyone else? Well, it all comes down to this really beautiful piece of cryptography that involves two keys. They're related, but they are very, very different. Let's look at the basic recipe.
It's really just a simple two-step dance. So imagine Alice wants to send some Bitcoin. In step 1, she takes her secret private key and the transaction details and she mushes them together to create a totally unique signature. This is something only she can do. Then, for step 2, she just broadcasts the transaction, that signature, and her public key out to the world. And now, anyone on the network can take her public key and instantly verify that her signature is valid for that specific transaction.
And this right here is the absolute key difference you have to understand. Your private key is your deepest secret. It's for signing. Think of it like a password that gives you all the power. You never share it, ever. Your public key, on the other hand, is for verifying. It's like a username or an account number. It's not only safe to share it, you have to share it so people can check your signatures and send you money.
Okay, now this is where things get really, really cool. It turns out a signature doesn't always have to lock in every single tiny detail of a transaction. Bitcoin actually allows for some incredible flexibility, letting you decide exactly which parts of a transaction you want to commit to.
Just imagine, maybe you're building a transaction with a few other people, or you want to leave some parts of it open for later. What if you want to commit to sending a certain amount, but you want to let someone else decide where it goes? This is exactly where that flexibility comes into play.
This is all controlled by these little things called sci-hash flags. Now, the default one, all, is what you're going to see 99% of the time. It just locks everything down. But you could also use none, which locks your inputs but leaves the outputs totally open for someone else to fill in. Or you could use single, which locks your inputs and only one specific output. These flags make all sorts of complex transactions possible.
A perfect example of this in action: crowdfunding. Let's say you want to raise funds for a project, but only if you hit a specific goal. Well, these flexible signatures make that possible right on the Bitcoin network itself.
By using this special modifier flag called Anyone Can Pay, you can sign your part of a transaction, but leave the inputs wide open. And what that does is it lets other people literally add their own funds, their own inputs, to your transaction. The whole thing only becomes valid once enough people have chipped in to meet the funding goal. It's a seriously powerful tool for collaboration.
Now, for most of its life, Bitcoin used one type of signature algorithm. It was called ECDSA. But a few years ago, a massive upgrade called Taproot introduced a new, way more powerful one: Schnorr signatures. And this wasn't just some minor tweak. Believe me, it was a revolution.
So what's the big deal? Why change? Well, the original algorithm, ECDSA, is mathematically pretty complex and rigid. Schnorr signatures, on the other hand, have this amazing property. They're linear. And that one simple property makes them more efficient, easier to prove secure, and it just blows the doors open for incredible new features, especially when you have multiple people trying to sign one transaction.
And that brings us to maybe the most powerful feature of Schnorr signatures:
their ability to work as a team. This is where that linearity property really shines.
So what even is linearity? Let me try an analogy. Imagine you can either bake two separate cakes and then stack them on top of each other, or you can combine the batter for both cakes first and just bake one giant cake. The final result is the same height, right? Well, with Schnorr, you can do the same thing with keys. You can combine individual public keys into one, or you can combine the secret private keys first to create that exact same final public key. It's a simple idea with massive implications.
And here's the crucial part, the big win. Because of linearity, multiple people can combine their public keys into one single aggregate key, and then they can work together to produce one single signature for it. It's called a scriptless multi-signature. And to the rest of the world, this complex, multi-party transaction looks completely identical to a simple, everyday, one-person transaction.
And this quote from the source material just says it all perfectly. To anyone who isn't actually part of the signing process, a scriptless signature looks exactly like any other signature. Whether it was one person or a dozen people, the final result on the blockchain looks the same. That is a massive win for privacy and for efficiency.
Now, with all this powerful cryptography, there is one golden rule. There is one mistake that can completely, totally undermine the entire security model. And it's all about keeping one part of the signing process truly random and truly secret.
This right here is the ultimate warning. When your wallet signs a transaction, it uses a secret random number just for that one signature. It's often called a nonce or K. If that same random number is ever reused to sign a second transaction with the same private key, an attacker can use some pretty basic algebra to figure out your private key and steal everything. It is catastrophic. This is exactly why you have to use secure, well-tested wallet software.
So these digital signatures are the absolute bedrock of Bitcoin security. They've evolved from just simple approvals to enabling these complex private collaborations. And the upgrade to Schnorr has kicked off a whole new chapter. These things are securing transactions today, sure, but the real question is, what new worlds of collaboration are they going to unlock for all of us tomorrow?